So in this question, we want to find the value of a that is going to make this function a continuous function. So our function is a piecewise defined function, and the first equation is x plus a. Now that's kind of hard to see. X plus a when x is less than or equal to 3. X squared when x is greater than 3. So we want to make a continuous function. And the first thing I want to think about is the individual equations here. Now, x plus a being any number will be a linear equation. Y equals x plus a will be a linear equation. And a linear equation is going to be a polynomial, and that is continuous over all real numbers. The second equation, y equals x squared, is a quadratic, which is also a polynomial function, and it will be continuous over all real numbers. So each one of the individual equations in our function are continuous everywhere. So we only really need to worry about the fact that a piecewise function takes these two pieces and tries to kind of join them together. So we need to make sure that at this spot right here, at x equals 3, that's the spot where we join these two pieces together, makes a continuous function. Now, there are, using calculus, 3 criteria for a function to be continuous at a point. So here are the 3 criteria. The first one is that f at that point is defined. So in our example, f of 3 is defined. The second criteria is that the limit at that point exists. So the limit as x approaches 3 of our function exists. And the third criteria to be continuous at a point is that the function definition from the first criteria and the limit from the second criteria need to agree with each other. That means that they're equal to each other. So this final criteria is that f of 3 is going to equal the limit as x approaches 3 of f of x. So for this function to be continuous, I need those 3 criteria to be met. So the first criteria, f of 3 being defined. So f of 3 is going to be 3 plus whatever a is. And so whenever we define what a is, this will be defined. Then, so that's our first criteria. For our second one, we need the limit to exist. Now, for the limit to exist, I need to be able to approach 3 from both sides, less than 3 and greater than 3, and get the same value. So in order for this limit as x approaches 3 of f of x to exist, I need the one-sided limits to exist and agree. So I need the limit as x approaches 3 from below of f of x to be the same as the limit as x approaches 3 from above. So let's try to calculate each one of these. So the limit from below, we're going to be using the first equation to find that limit. Below 3 is less than 3. So that's going to be 3 plus a. And then to find the limit as x approaches 3 from above, we're going to use the second equation. Above 3 is more than 3. And so we'll do 3 squared to get that. 3 squared is 9. And we need these to equal each other so that the limit will exist. So this is going to give me an equation where I'm able to solve for the value of a. So 3 plus a needs to be 9. I'll subtract 3 and get a equals 6. So in order for that limit to exist, a needs to be 6. And once that limit exists, then it'll also match the function value as well. The 3 plus 6 would be 9, and all 3 would be 9. So we need a to equal 6 in order to make this a continuous function. So that would mean the function would be x plus 6 when x is less than or equal to 3, x squared when x is greater than 3, and we can double check our continuity criteria. So criteria number 1, f of 3 is defined. F of 3 will be 3 plus 6, which is 9. We use the first equation because it has the equal to. For the second criteria, we're going to do the limit as x approaches 3 from below. From below, that's 3 plus 6 is 9. We use the first equation because it's got a less than 3, that's below 3. The limit as x approaches 3 from above. This time we use the second equation. Above 3 is greater than 3. That's 3 squared, which is 9. Because the limit from below is equal to the limit from above, that means that the overall limit is 9, exists and is 9. So the second criteria is met. The limit exists. And the final criteria is that the function value and the limit agree with each other. So f of 3 does equal the limit as x approaches 3 of f of x. They both come out to be 9. And so that means that this function is continuous at x equals 3. So for this question, we want to use the table to approximate the value of the limit. And we want to find the limit as x approaches 0 of our function f of x. Now, as we look at the table, we want to see how the table was constructed. The limit we're interested in is approaching 0, and I can see 0 is in the middle of the table. When you find a limit, you need to approach that value from either side, from below and above that value. And so I can see that I've got numbers that are below 0 on the left and numbers that are above 0 on the right. As I look at the numbers, negative 0.1 is the furthest away, and when I say furthest, I'm talking about on the real number line. This value is the furthest away, and this one is getting closer, and this one is getting closer. So as I'm looking at these x values, they are getting closer to 0, and all of these numbers are below 0. So that's going to indicate to me how to read the y values. So on the other side, I can see that on the number line, 0.1 would be the furthest away from 0, 0.01 is closer, 0.001 is closer. So this table has been built to look like the number line. So we're going to approach from below to see what the limit is, and approach from above to see what the limit is. For this limit to exist, we need them to be approaching the same value on either side. So as I look on this side, look at this group of y values. I've got 2.01, 2.0001, and 2.000001. So it looks like to me that these y values are getting closer and closer to 2. So we're going to say for the one-sided limit, the limit as x approaches 0 from below of our function f of x is equaling 2. So then I'm going to look at the y values on the other side to see what's happening from above. And when I look at these y values, negative 2.8, negative 2.98, and negative 2.998, they look like they're approaching negative 3. So I'm going to say that the limit as x approaches 0 from above this function f of x is approaching negative 3. Now for this limit to exist, I need these limits to be approaching the same value. So because they're approaching different values, we're going to say that this limit does not exist. So the limit as x approaches 0 of f of x does not exist because the table shows me that the y values are approaching different values on either side of 0. Thank you for checking out my videos. Have a great day.